The real magic lies in the new parameter, the feature that gives NuSVC its name and its adaptability. Think of it like the distortion pedal of a guitar. You're in control, dialing in the balance between precision and flexibility. Set nu to 0.1, and you're effectively saying, I'll tolerate up to 10% error, but give me maximum margin and flawless performance everywhere else. This parameter isn't just a technicality, it's a game changer, letting you tune the model's behavior to match your dataset, whether it's noisy, imbalanced, or just plain unpredictable. And here's the kicker. Unlike many algorithms that fold under the pressure of high-dimensional spaces or overfitting, NuSVC thrives in these challenging environments. It's the band that keeps playing, louder and sharper, even when the stage starts to fall apart. Whether you're tackling multi-class classification, noisy datasets, or looking for a robust solution that adapts to your needs, NuSVC steps up and delivers. So let me ask you this. If NuSVC were a band headlining your machine learning lineup, how would you use it? Would you tune it to perfection, push it to its limits, or let it guide you through the chaos of your data? Stick around, because we're just getting started, and the performance NuSVC is about to deliver will blow you away. Imagine you're at the controls of a soundboard, and one particular slider determines everything: precision, adaptability, even the overall harmony of your machine learning performance. That slider, it's the new parameter, the secret sauce of NuSVC that takes it from just another classifier to a highly adaptable powerhouse. The new parameter isn't just a number, it's your key to unlocking the perfect balance between complexity and error tolerance. It's what sets NuSVC apart from traditional classifiers. At its core, NU is a regularization term, but what makes it extraordinary is the level of control it gives you. Think of it this way. Setting nu to 0.1 is like saying, I'll allow up to 10% of my data to be misclassified, but only if it means my model can find a hyperplane that maximizes separation everywhere else. It's a trade-off, yes, but one that puts the power squarely in your hands. Now, let's talk about what this means in practice. When you set a low nu value, you're telling the model to focus on precision, keeping errors to an absolute minimum. It's perfect for datasets where every misclassification could mean significant consequences, like medical diagnoses or fraud detection. On the other hand, a higher NU value gives the model more room to breathe. It's like loosening the reins, letting the algorithm explore more flexible solutions, which can be critical in noisy or imbalanced datasets. But here's the twist. The impact of nu doesn't stop at error control. It also plays a huge role in how complex your model becomes. A lower nu value pushes the model toward stricter boundaries, potentially increasing complexity and the risk of overfitting. A higher nu value, it smooths things out, often leading to simpler, more generalized solutions. That's why mastering this parameter isn't just about picking a number. It's about understanding your data and the trade-offs you're willing to make. And the range of nu, it's as intuitive as it gets, 0 to 1. Yet within that simple range lies an enormous amount of flexibility. A 0.1 nu value gives you up to 10% misclassification, while a 0.5 value allows for 50%. But here's the real power. You get to decide. The model adjusts to your specific needs, whether you're tackling a noisy dataset, dealing with imbalanced classes, or searching for the perfect balance of flexibility and precision. So as you adjust your new slider, ask yourself, what's more important for your project? Rock-solid accuracy or the ability to adapt to the unique quirks of your data? With NuSVC, the choice is entirely yours, and the possibilities are endless. Ready to see how this parameter transforms your classification game? Let's dive deeper